So this is part 2 of the on-site psychometrics day, and we're going to run an exploratory factor analysis using SPSS. Okay, so remember, in exploratory factor analysis, you don't tell the computer what variables you think load on quant or verbal. You let the computer take those 6 variables and come up with a mathematical solution where they're trying to reduce the data, right? Parsimony is key. That's the whole intent. You don't want to give somebody 100 items and so much subject burden when you're trying to get at an underlying construct. You want to use as few items as possible, but you also want to know if some certain items, if they're redundant in the fact that, or do they have some shared space. You can be redundant and not be totally redundant, completely redundant, just has some shared space. You want to know, are some measuring some underlying subconstruct and others measuring a different one, like quant and verbal, okay? So in SPSS, we're still working with a quant and verbal Chromax data set. You go to analyze, a data reduction in factor is the first thing you do. And when you do that, you're going to get the interactive dialog box that looks like this. And we're going to pull over our variables. Okay, so let's start. So here's the data set. We're going to go to Analyze, Dimension Reduction, Factor, and pull over the variables we care about for this. Those 6 exams these young boys took. Maps, Calculus, History, Probability, Gaelic, and Algebra. Okay, and you can get descriptives again. Right here, right, with the initial solution. That's fine. You get a univariate descriptives, which is what you ran when we first did part 1, right? You can. You don't need it, but you can. You want to get the KMO and Bartlett's test of sphericity, and we'll chat about that and hit continue. And for extraction method, unrotated factor solution and check scree plot, and hit continue. Rotation, we're going to be doing Baramax first, and right, we're doing orthogonal. Let me just double check your handout. Screen plot and continue. Orthogonal, yep, Baramax. Okay, meaning that we're saying that those we're not asking it to come up with an optimal solution, assuming that those subconstructs are correlated. So let's get back in here. Now we're doing Baramax. No. Look at your handout. Yes. Okay. Great. Click off loading plots. Continue. I think that's all I brought you through on this handout. Okay, we got Varimax. We clicked off loading plots, main menu returns, and hit OK. Perfect. Yep, that's it. Okay. Oh, we got output, which is great. Okay, you're not going to read it yet. Let me go back. I want to stay with your handout. Okay. You're now on page 17. We have your output there. We'll chat about it in a few minutes. So the Varimax goes from page 17 to page 23. Perfect. So let's take a peek at your output. All right, so here you just get the output telling you what you ran, kind of like your syntax, right? It gives you your syntax, when you ran it, what data set you used it to do it. It's going to give you something called communalities, which tells you how much how much the underlying factor actually is part of each of the variables. What I want to bring you first to is the total variance explained. What this is telling us here is that it believes we have a 2-factor model, right? Because here's components, 1, 2, 3, 4, 5, 6 factors. It's telling us there are 6 components for possibly 6 factors because there are 6 questions. And if you come over here, and I'm going to talk to you about eigenvalues in a few minutes, but if you come over here, it's telling us the cumulative variance, total variance explained with your model. If there's only 1 factor, we're explaining 60% with the initial eigenvalues. And if we do a 2-factor model, we're at 77. If we do a 3, we're at 92. But it's just actually 78 if you round that up, but it's looks like it's thinking it's a two-factor model. We should come over here. It tells you again what the rotations of the sums of the square loading. Again, the variance that's explained from the total variance. So it's actually looking like it thinks it's a two-factor model. So the takeaway, the gist for quantum verbal, it thinks it's quantum verbal, but there's still some variance not explained, and let's look at that. So I'm going to first look at something called the discrete plot with you next, and then we're going to look at pictures, because I think pictures are really helpful. So discrete plot's another diagnostic when you're trying to say, hey, how many factors are actually in this exploratory factor analysis? And again, it gives you 6 as the possible underlying, because there are 6 components or 6 items or questions in the overall scale. And you read an eigenvalue above 1 makes it a factor. So this is your cut point here, that 1. So it looks like it's probably a two-factor model here as well, with this little, maybe little mini factor here, right, coming up with this one question that might be have a fair amount of, might be its own little mini factor, but we'll see. And we thought that when we looked at the initial correlations, right, the initial Cronbachs, and we're getting that same feedback here. But overall, there's one real strong factor, another one, and then maybe a third. Okay, that's looking at your discrete plot. And before we get into looking at the components analysis and rotated, I want to take you to another picture, because I think these really help. Look at this. So do you see in the component plot and rotated space how probability, algebra, and calculus are all sitting together? I always think of this as, there was one movie that they had the kids in a cafeteria, comedy, a teen comedy, where someone drew the cafeteria and said, you know, this is where the kids who like bands sit, these are where the kids who like sports sit. And they have, so I think of it like that, like here's the math, right? The math's the quantitative. Gaelic and maps are over here, and here's history. So history is kind of near maps and Gaelic, and these two are kind of near each other, and they're all kind of near each other. But these 3 are definitely, remember that Cronbach's apple was above a 0.9 for those 3? They're definitely all grouped together. So it looks like it probably is a two-factor model, maybe a 3, okay? But what I really want you to do now is you're going to change your rotations to something called ob-lim-in, which is where you actually let those subconstructs be correlated and see if it changes what happened, okay? So we're going to go back to, I think I just give you output, I do. So let's go back to SPSS. We're going to analyze, dimension reduction, factor, and leave everything as is, just change your rotation. You can change it to ob-lim-in. We will actually let those subconstructs have some, like we move it around and say, hey, they might not be orthogonal. They might not be at 90-degree angles to each other. They might have a little more in common. And hit OK. All right, and to keep it straight, because there's so much output, remember over here we have this little handy index to see this is, like here's your factor analysis. And then here's another fact, like it actually lets you know what you're doing. Like you can go click the different ones and see what's happening. Brings you to the different spaces, and to know which analysis you did, right above it has the syntax. Here's my ob-lim-in rotations. They're right here. So here's the correlated ones, and this one, the rotation is Baramax, orthogonal. That's when we just walked through. Okay, and here's the ob-lim-in. Okay, so what we didn't talk about was something called on the initial on the orthogonal factor solution. We didn't talk about the initial test that you looked for, so I'll walk you through it on this one. So you do the factor analysis, and again, you can get some descriptive statistics. What pops up next is something called the KMO, which is the Kaiser-Meyer-Olkin measure of sampling, and then the Bartlett's test of sphericity. And what these do are these just kind of like 2 litmus tests that tell you, hey, should I proceed or not with this before I actually start interpreting the whole exploratory factor analysis? And in order to proceed, the KMO should be above a 0.6 or 0.65, so above a 0.600 or 0.650. And the Bartlett's test of sphericity should be less than 0.05 in the p-value, and indeed it is. So they both pass that litmus test. You look here, 0.668, right, with the orthogonal solution, and a 0.008 in the significance. So again, above the 0.6 and below the 0.05. Okay. So you could move on and then look at your data. So we're going to. All I think the last thing we're going to run is a correlation with the analog, but I think I'll do that in the end or in another podcast. So let's start up here. So what we did here, we did our principal components extraction. I got our univariate solutions, slide on down, our KMO. Looks good, it's above a 0.6 or 0.65. Our Bartlett's testosphericity is below a 0.05, so we can proceed. All right. I walked you through that two-factor model it's thinking it is, and again, it is indeed telling us it thinks it's a two-factor model, giving us two factors explaining 78% of the variance. We're not missing any data. And the scrape plot, if you draw that line there at the elbow, it looks like there were two factors, right, with that have an eigenvalue. There are two with the eigenvalue above 1, so it's probably a two-factor model. We might have a mini factor. I'm going to walk you back through the rest of these numbers, and on the on-site day, definitely walk you back through the rest of the numbers. This is just to give you a start, and I'm going to let you read a handout that also walks you through these numbers. And the takeaway here is looking at these, that it looks like we have one factor here, quant, maybe one here we can call verbal, but not as highly correlated with each other. Okay, getting in now to the Oblomin rotations, where we let the two subfactors correlate with each other. And we're actually rotating it in space. Again, no missing data, KMO and Bartlett's are fine, two-factor model. Scree plot looks like right above that bend in the elbow, we have 1, 2, maybe a third subfactor, but it's still doing a two-factor solution. I'm going to walk you through the component and pattern matrix and structure matrix with your data individually too. And here again, now you see we rotated them. Since we allowed it to rotate, it's telling us looks like maps and Gaelic might be together and history over here, that little third mini subfactor. And when we go back to the Chromebax alpha for verbal that we did, remember with the Chromebax alpha, if we deleted an item, if we deleted history, the Chromebax between maps and Gaelic went up. Pretty neat. And if you delete maps, the Chromeback between these two would drop to a 0.204 between history and Gaelic. So let's see how they're sitting in our picture. Here's history, here's Gaelic, and maps is the thing kind of holding them together. So that's pretty neat, right? So allowing it to rotate really clarified that. When we saw that, you know, when you're trying to get a patient's diagnosis together, you do all the differential diagnosis and little things to see if they're aligned. So you first say, for us, analogous, here's their KMO. Yep, they passed that. It's above a 0.6 or 0.65, depending what you read. The Bartlett's testosphericity, you want it below a 0.005, below 0.05. For the alpha for that. Yep, they passed that. That looks great. Okay, let's look at the total variance explained. It looks like a two-factor model that's explaining about whatever it was 79% or 78%, but it looks like there might be a little mini factor there. And we had thought that with our descriptives too, right? And then we ran our Chromebacks, looked at item, if item was deleted, what would happen in those. So pretty neat. And we also knew that those items we're calling quant, and the other one I'm calling verbal, that they're negatively correlated, a lot of them. So we know that they have to definitely be looked at as subconstructs here, right? Because there are different things there. And then the other thing we looked at with the Scree plot again, to say, okay, looking at the Scree plot with the eigenvalues and that picture with the bend at the elbow, right? How many are above 1? We're too strong. And then there's usually one big subfactor that, you know, one factor that everyone runs to that has, you know, soaks up most of the variance. And then there's another one, but it looked like there might be a third one popping up. And when we ran it where we allowed you know, to change and not have them orthogonal, you know, at 90-degree angles, see how they're spreading out now over here? This verbal, as I'm calling it, and it might not be verbal, it's just a convenient label, but definitely different from these guys. So that's the beginning of exploratory factor analysis. That's actually quite a lot to begin with. And I do want to give you another handout that's up already, and you'll get it anyway, on how to actually read some some of this output, and it is already up for you. It's a very nice handout on how to read psychometrics here. So two, a great website to interpret factor analysis, and then factor analysis and UCLA ATS, their output, their document, just how to actually read it, okay? So that concludes the second podcast in On-Site Psychometrics Day, and you will get a third podcast and run through this exactly with these steps. So, you know, and you can change the descriptives, that's up to you, and what you click off, but run through it, do the orthogonal rotations, and then do the non-orthogonal rotations, Varamax and Oblomin and SPSS, those are your choices there, and see, you know, how it looks and what it looks like to you, all right? So, and then you'll get one more podcast on actually interpreting all the data a little deeper. Like we just did the first, you got enough here for now. I definitely think so. And then we'll do the next one where you get the whole kit and caboodle.